looking at 7.4. This is going over logarithmic functions, finding the inverse of those. So when we're talking about finding the inverse, basically you're just going from the exponential to the log function, or from the log function to the exponential. So when it asks what is the inverse of f of x equals 2 to the power of x, well, the inverse of that is just going to be the log function of that. So it'll be log 2 of x. So when you have a number to the power of something, it almost shrinks down and you put the log in front of it. So I'm still going to have the 2 and the x. We'll just put log in front of it. And so it's log 2 of x. And that would be our inverse function, and we'll start writing that as f negative 1 of x to show that inverse. And then when I go to graph this, we're always going to graph the exponential first because we can work through that a little easier versus the log function. We've got to do a few more steps. On this exponential, if I put in 0, remember anything to the power of 0 is 1. So that would be 1. Then I'm doing 2 to the first power, the second power, third power to give me 2, 4, and 8. Remember, since this is a 2, when we go up by a factor of 1 on the exponents, it's just doubling each time. And that means if I'm going down, it's just going to half each time. So from 1, it'd go down to 0.5 and then 0.25. Now, the nice thing about knowing that these are inverses is that when I'm looking to graph them, instead of having to find points for the log, I can just flip this around and make my f of x values, or my y values, my x values, and my x values, my y values. 0.25, 0.5, 1, 2, 4, 8. Okay, so now we've got both of those written down in a way that we can graph them. So I start out normally on the 0, so 0, 1, 1, 2, 2, 4, and 3, 8. And then we'd go down to a half and a fourth. Really all that's doing is just putting this down to where you more or less ride that line on this here. So there is our 2x function. And when we graph the log function, again, I'll start at 1, 0. And then when I go to 2, it's at 1. 4 is 2. And at 8, it would be 3. And then we have our 1/2 and 1/4, which is really just bringing it down close to the line on this line. And bringing it up right through there to get our inverse function. So we'll label that as this one's f of x. This one we'll label as f negative 1 of x to show that it's the inverse. And then I can put my dotted line that we're always going to use to show where that reflects upon itself. And last but not least, it asks us about the domain and range of each. So if we look at the domain here on my function, original function f of x, it's going out all the way to the left. There's nowhere where it's going to stop on the right. You can also think about that as I can put in any number that I want to for x, negative 1 million, positive 1 million, like anything in between. So my domain then is going to be all real numbers. Thinking about the range, when I put in those numbers for x, and you can test this out, if I put a negative 1,000 in here for x, for instance, it's going to give me a really small decimal number, but at no point will it ever be negative, and it actually won't ever even get to the 0, because cutting something in half is never going to get it to be nothing. So that y value, and just y is greater than 0. because this one is going to keep going up and up forever. But this one stops short of that 0 mark. And looking at my inverse function, we're kind of swapped here. So it's going definitely down, and it goes up and out, but as it continues to go up, since there's no value I can't put in for x here, that means there's no value that can't be y here. So my range on this one is going to be all real numbers. My domain, if I look, this is going to get closer and closer to the y-axis, but never actually cross it. So again, the range and the domain swap here, and instead of y, we'll write it as x is greater than 0. That gives me my domain and range for both. And looking at number 2, what happens here is you've got log 3 of x, and talking about inverses, we're just going to now magnify that 3x, or magnify the 3 really, and it's going to turn into 3 to the power of x. And so anytime I've got this, we are going to graph the exponential first and then leave the log function. So and what's going to happen with this is that graph is going to look almost exactly the same as this, just a little bit steeper. And so for time's sake, I will leave it for now and give you a sort of shot of this at the end. But just know it's going to look just about the same as this. Domain and range are actually going to be exactly the same. Okay, on my other side, now we have a decay function, and so we just want to see what it looks like when it is a decay function. This part's going to, doing the inverse is going to work the same. The inverse of this is going to be log 1/2 of x. And so when we go to graph this one, let's do -2, -1, 0, 1, and 2. If I do anything again to the 0 power is still 1. And to the first power is just 1/2. When I square it though, 1 squared is 1, 2 squared is 4. So that'll be 1/4. Then remember when I go to the negatives, it's giving me the reciprocal. So 1/2 reciprocal of it, or flipped over, would be 2 over 1, or just 2. And then -2 power would be 4. And for our log function, of course, since it's the inverse, we're just going to swap those, which would be a lot more confusing to figure out had I not worked it out this way, trying to plug numbers into the log function and work it out that way. And hopefully, as we've gone through the last unit and this unit, you're getting an idea of how these log functions work and seeing the way that they kind of go and move as we go along. But graphing it out, 0, 1. At 1, I'm at 1/2 and then 1/4. So kind of like the first one we graphed, just going opposite. 2, 4, and 3 would be up here at 8, -3, 8 rather. So graphing this out, it goes up that way and up here. There is our original function here, 1/2 to the power of x. Now I'm going to go ahead and put this line in the middle because I want to see as we go along what it looks like, because it works in a little different way just because of the way that it crosses. We want to make sure we are aware of that as we kind of go over it. So let's do this one in a different color just to make sure that we're going kind of in the right way. So we'll start out at 1, 0, so close to where the other one is there. And we'll continue when x is 1/2. Well, let's go the other way first. When x is 2, it's at -1. And when x is 4, it's at -2. And when x was 8, it'd be right there. So if we look at the way this one's coming down, kind of going in the same way. Then 1/2 and 1/4 up there. So we know it comes down following this line and then moves out that way. So hopefully the colors help a little bit, but you can kind of see the mirror of this line and this line. I could go point for point and they would be opposing each other on each one. And same thing here, that we graphed it out with those points, and so you can kind of see the mirror image as if I was to fold it on this line right here. They should match up perfectly on one another because that's what it does when you've got a reflection. Okay, looking at the domain and range for this. The domain, starting out here, it still goes moving left, moving right. So my domain is going to still be all real numbers. And in the same way as that first one, doesn't ever cross the 0. So you'll be y is greater than 0. And for my other one, again, it's going to swap. So x is greater than 0. And my range is going to be all real numbers. For the last one here, again, like the second one, this is just the inverse of this. So we have the log function, and we'll zoom into this and end up with 1/3 to the power of x. And so that would be our inverse function. We'll graph it in the same way. Just make sure to graph this one first. And domain and range is going to work in the same way. My domain here is just going to be all real numbers. Range is y greater than 0. And for this one, that'd be my swapped. Like x is greater than 0. Range is all real numbers. So there's that function graphed out. Again, about the same as the other one. Colored the lines differently so we'd see difference between the f of -1, which is working in the same way as my original function for number 3, and the f of x, which looks like the inverse.